All right, you guys. This is going to be the test 6 review. I'm going to go ahead and just go over all the questions. I'm going to use some of these steps that we talked about in class. Remember some suggestions that I gave you. Be able to decide, am I using this formula, or is that something I can use? Can I use the TVM calculator, the time value money calculator, on my TI-83? Or is it, with the CD, am I not able to use either one of those? The other thing you need to think about, and remember we added this bullet in the middle of these two, was, is it an investment or a loan? The reason why it's nice to ask yourself that question is because when we talk about an investment, I'm going to open up a new flip chart. A loan versus an investment, some things come to play, especially when we're using that TI-83 calculator. So if it was me and I was writing notes, extra notes on that on my review, these are some things I would write. If I know it's a loan, then a couple things have to happen. First off, your PMTs, or the payments that you're plugging in, payments are negative, versus over here, payments are positive. Another thing that you got to remember when you're dealing with a loan, we want the future value of a loan to be 0. And so for our instances, when it talks about paying off a loan, FV is going to be 0. One of the nice things about that is it's just one less thing to plug in when you're talking about your time value of money calculator. It helps you out in that instance. So those 2 things, or those 3 things, are going to be important for you to be able to make this decision. Is it an investment or is it a loan? We also I'm going to try to write down the variables that we're looking for in each of these questions, perform your operations, and lastly, make sure you put them in context of the situation and see if it makes sense. All right, so the first one, suppose you wanted to invest $5,000 into a savings account with 3.5% interest rate compounded monthly. What would be your balance in the account after 15 years? So we could use this if we wanted to because it's a savings account. Remember, we talked about you can use this if there's no payment. So like savings accounts would be a situation where we could use this as long as we're not paying into the savings account. But instead, I'm going to use that TVM calculator because to me it's just easier. I'm going to look and say, is it an investment or a loan? So in this case, it uses that keyword invest, so I know it's an investment, which I'm just going to write off to the side. And then also I'm going to write what it's asking for. It says, what will your balance be in the account after 15 years? So after 15 years means that it's looking for the investment or the value of the investment in the future. So I pull up my calculator. I go to my TVM calculator and I can plug these things in. I'm not going to do this every time, but one thing you might also consider doing before I go to the calculator is just highlighting the important information. 5,000 into a savings account, 3.5% interest, 15 years. You got this idea of compounded monthly. All of those are some keywords that you're going to need to be able to understand how to use with your TVM calculator, your time value money calculator. So you want to invest $5,000. We already know we're looking for our future value, so that's kind of eliminates the fact of guessing between those 2 things. But you're investing, so your present value or your principal value of $5,000. Your interest rate, 3.5. Don't forget, we don't have to move a decimal. It's already asking us about percent. So it's looking for a percent. It says interest rate compounded monthly, so that means I'm going to come down here and I'm doing monthly compounds. Since there is no payment, that my interest is my only payment, that's also going to be 12. And then the last thing, it says after 15 years, so I'm going up to my N and I'm going to type in 15 years times 12 payments a year, or 12 compounding periods, and that'll automatically give me 180. So in this case, we have no payment, so we have to set the payment equal to 0. There's no monthly addition to the account. And we're going to keep it at beginning right here. For our purposes, I will be explicit as whether or not I want you to do beginning or ending. Otherwise, keep it with the beginning. And then we're going to solve by pressing alpha and enter, and we get $8,445.84. Excuse me. $8,445. I think it's at 84 cents, correct? A couple things I want to make sure that we talk about in context. Y'all, we're talking about money. When you're talking about an investment, even though this says negative, think about it in context of the situation. You're not going to have a negative amount at the end of an investment. Otherwise, it'd be the worst investment of the world. Second thing, I know there's all these decimals, and I'm not stressing about rounding, but you don't have 0.837977 dollars, right? You don't have that. So when you think about money, you need to think about, we don't need these. So even if you're struggling on rounding, just cut it off at 83 cents. Really, though, it should be rounded to 84 cents. So then that's what you have for number one. Number two says you decide that you want to invest money in a CD at the bank. You decide that you can invest $400 and are told that your CD will have a simple interest rate of 4.25%. How much money can you expect from each interest payment? Now remember, with a CD, we're not using this. This is for compounding interest, and we're not compounding interest in this case. We're also not going to use our TVM calculator. All it's asking for is, based off of a CD, how much can we expect from our interest amounts? And so I'm not even going to write these four key things, because all we're doing is we're going to multiply the $400 times my interest rate. Remember, we have to write that as a decimal, 0.0425. Couple things in case you're struggling with this. A lot of people are struggling with, how do I get this as a decimal from an interest rate? We always just kind of talked about moving two decimal places, but if that's something that you're struggling with visualizing, you can always take your percentage rate and divide by 100, and it'll give you what you're going to multiply by. So in this case, we don't need our TVM calculator. All I'm going to do is multiply 400 times 0.0425, and we get $17. I saw a couple people that when we did this in class, they did not take in consideration moving the decimal. I want you to see what happens. So it wouldn't make any sense if we invested something and we got 4.25% simple interest for us to get that much money as an interest payment, $1,700. And so that should be like that warning sign going off in your head. I screwed up somewhere. In context, it doesn't make any sense. And then you might go back and change your decimal. So just keep that in mind. Number three says you decide you want to buy a car. You go to the local car dealership and are pre-approved for a $25,000 loan with a 5-year 2.75% interest rate compounded monthly. How much should you expect your monthly payment to be? So the first thing I'm going to recognize is that it's a loan. The reason why that's nice is because it tells me my FV has to be equal to 0. And then it's asking for my payment. That last question is asking for the payment. So just giving myself some key things to be able to recognize when I'm going to my TVM calculator. So I got to use this. I go to my apps, my TVM solver, and in this case, let's start from the beginning. It says we're pre-approved for a $25,000 loan. So my loan payment, a lot of people were like, well, is this, future value, present value? Well, if we know it's a loan, our future value's got to be 0, so that eliminates that. And then we end up having a present value or a principal value of $25,000. So it's a 5-year loan. So we're going to come up here. It's a 5-year loan, and we're having monthly payments. So 5 times 12, your interest rate, 2.75. PV we've already decided. We want to know how much your payments are going to be. Before we do that, let's just double check and make sure this is right. Monthly payments means that your payments are going to be 12 per year. So that's correct. And then it says interest rate compounded monthly. Since it says compounded monthly, we'll have 12 as well. We're going to leave our payment occurring at the beginning because it's a loan. And we're going to solve for our payment. So alpha enter. And we get a payment of $445.42. All right, let's go to number 4. It says you racked up $4,000 on your credit card debt, and credit card debt, you cut up your card and plan to pay it off. The interest rate on your card is 18.99%, and you can afford monthly payments of $350. How many payments will it take you to pay off your card? So in this case, we're looking at a loan. It's credit card debt, so we know our future value is 0, and we're looking for how many payments. So we're looking actually for our N in this case. And so let's go ahead to our TVM calculator. We know we're looking for N. I'm going to put a 0 as a placeholder. We have our interest rate of 18.99%. Our present value was the original $4,000. We know we can make payments of $350. Don't forget, you need to have a negative payment, like we talked about at the beginning. So payments are negative. Your future value is 0. Let's double check. We have monthly payments, so your PY should be monthly because of monthly payments. And then it doesn't give us a compounding period. So since it's a credit card, we're just going to assume it's compounded monthly. And we're going to go ahead and find or solve for N. So then we'll press alpha, enter, and we end up with 12.48. 72300 Obviously, in context, it doesn't make sense to have that 0.48 payments, right, or so forth. And so in this case, 12 payments is not going to get the job done. 12 payments would still leave us with a chunk of money based off of this decimal. And so based off of the context, we're going to say 13 payments. Now, the 13th payment will not be the total $350 because we don't need a whole payment. That's what that 0.48 was symbolizing, but we will need a 13th payment in real life, even though it's less than $350. All right, straight up differences between a CD and a savings account. A CD, you have simple interest. And you get a penalty if you touch your money. And what I mean by that is normally with a CD, you tell the bank that you're not going to touch your money for 3 years or 5 years or 1 year or whatnot. If you do it early, if you go in and say, I need this money, I understand I can receive a penalty, that's what happens is they give you a penalty. With the savings account, you have normally compounded interest. It can be compounded in very different ways: monthly, daily, bi-monthly, yearly, weekly, but you have compounded interest, and then you also have no penalty. That's your money. You can go in and touch it anytime you want to. Those are the two big main differences that you need to be ready for. All right, moving on. Number 6, you want to buy a car, but you're scared you can't afford. All you can afford is a hoopty. Based off of your meager Wendy's income, you decide that you can afford monthly payments of $200. You went to the Bank of Branson and estimated that you could get approved for a 4-year loan with 6% interest rate compounded monthly. What's the total value of the loan that you should take out? So we have a loan, which means future value is 0, and total value of the loan that you're going to take out, well, that means I'm looking for my PV. So we're going to our calculator. It says you can afford monthly payments of $200. Don't forget, payments are negative. So we got that fixed. You went to the Bank of Branson, you get approved for a 4-year loan. So up here on your N, 4-year loan, and you're going to be making monthly payments. So that's what it said right there, right above the calculator, monthly payments. So 4 years times 12. Our interest rate was 6%. Your PV is what we're solving for, so I'm going to put a 0 right there. Your payment of $200, don't forget future value stays 0 because we're talking about a loan. Your payments per year, it was monthly payments, and so that's 12. That's good. And then your compound periods, compound monthly, so then there's 12 right there as well. And then we're going to solve for our present value. How much of the loan should we take out? Alpha, enter. $8,558.64. $8,558.64. Recognize again, we're putting it into the context. I don't need all these decimals afterwards. In the context of the situation, we leave it like money. All right, number 7 says you decide that you're going to invest your Christmas money into a savings account. The savings account that you choose has a 3.5% interest rate compounded weekly. You plan to put the $200 that you got for Christmas into the account and not touch it for 4 years. How much money will you have in the account after 4 years? So this is an investment. which means we don't know anything about the future value, but we do know our payments need to be positive. And then let me see what I'm looking for. How much money will you have in the account after the 4 years? So after the 4 years symbolize that we're looking for the future value. So we should have everything else that we need to plug in. All right, let's start with what we see first. Excuse me. It says 3.5% interest, so I'm going to go down to my interest rate and go ahead and do that. 3.5%. Compounded weekly, so now we're going to come down here. Compounding periods is 52. You plan to put $200 into the account and not touch it for 4 years. So in this case, the only payments that our account's actually getting is going to be from interest. Since our interest is compounded 52 times a year, your payments will happen 52 times a year because that's how you're seeing payments is through your interest compounding. Our payments, like we said, in this case, you're not adding any extra money. You have one original payment, but that's actually the present value. So this $200 is going to be our present value. We have our 3.5%. We're not paying any extra money into it. And then we need to change our end value. So it says 4 years, so 4 times how many payments we have per year, 52. And now we can go down here and solve for our future value, alpha, enter, $230.04. Now, I know that's not a large chunk of cheese, but you're only doing it for 4 years, and you only have a 3.5% interest rate that is divided into weekly compounds. So that's 52 different compounds a week that you're dividing this 3.5% interest. So you're barely getting pennies every week in that situation. That's why it's not that much. Number 8 says you decide to take Mr. Branson's advice and buy a house that you and your buddies can live in while you attend college. The house that you decide to buy is $110,000. You go to the local mortgage lender and get approved for 30-year mortgage loan at 5.35% interest rate compounded monthly. How much is your monthly mortgage payment be? So this is a loan. Since it's a loan, we know that our F fee is 0, and we're looking for mortgage payments. So PMT is what we're searching for. We go to our calculator. It says the house that we decide to buy is $110,000. That's my original. Excuse me. The house that we decide to buy is $110,000. $110,000. You go to the local mortgage lender, you get approved for a 30-year mortgage loan. So 30-year mortgage. For 12 monthly payments, so you have monthly payments, 5.35%. Your payments is what we're searching for. Future value is a loan, so that's going to be 0. We're making monthly payments each year. And my interest rate is compounded monthly, so that's how I'm getting my 12 from the monthly payments. My compounding periods per year is 12 because it's compounded monthly, and we're going to solve for our payment. $611.53. Not bad for a $110,000 house. Number 9, you're trying to decide between 2 different bank loans to purchase a car. One bank loan will give you $15,000 with a 5-year 4.35% interest rate. The other bank loan will give you $15,000 with 4 years 4.25% interest rate. Which loan will cost you more money per month, and which loan will cost you more money over the life of the loan? So in this case, we know we're dealing with loans. Future value in both cases is going to be 0. So we actually have 2 scenarios. So I'm just going to split this down the middle. And we're going to look at the first one. So the first one, we have a 5-year loan with monthly payments. So 5 times 12. The first one has an interest rate of 4.35%. And my present value is the $15,000. That's how much we're borrowing. We're looking for a monthly payment. My future value is 0. Payments per year, we're going to make monthly payments per year, and compound interests is going to be 0 as well, or 12 as well, excuse me. Solve for your payment. So this one's $277,000 or $277.62. $277.62. And now we're going to solve for the other one, which instead of 5 years was only 4 years, so 4 times 12 for your monthly payments. The interest rate was different. It was a 4.25% interest rate, so a little bit better. $15,000 is still what you're trying to save, and so now we're going to solve for that. Well, that payment's going to be $339.17. So this is per month. So monthly, it's more advantageous for you to be able to do this because you have more money to spend on McDonald's and all that mess. But we'll see here in a second that it might not be the best case in terms of overall life of the loan. So you're paying this a month for your first bank, and you're paying it for 5 years, which would be 60 payments. So in this case, I'm going to go to my calculator, and I'm going to see how much I would pay in the life of the loan by taking the amount that I pay per month times 60. I'm getting 60 because it's 5 years and there's 12 months in each year. So this one I'll be paying $16,657.20. And that's for the whole loan. If I go to the other one, it's going to be $339.17, but this one was only 4 years. So that's only going to be times 48. $16,280.16. $16,280.16. So over the life of the loan, this one, even though my monthly payments are more expensive, I'm saving myself, roughly $350, $370 by using this bank instead of this bank. However, this bank is better on the months. And so you need to be able to consider how to compare two different scenarios like that. All right, so number 10 says you want to buy a television at Best Buy and are planning on using a credit card to purchase it. Your credit card will give you a special interest rate of 3% compounded monthly. You pay off your balance in 18-month payments. If you can only afford $100 monthly payments, how much do you spend on the television? So it's a loan. Future value equals 0. In this case, we are looking for how much we can spend on the TV, so we're looking for our PV. Sorry, not equal to 0. Question mark, and we go to our calculator. Go to your finance app, and let's go ahead and plug these in. So this one, it says 18 monthly payments, so we don't have to multiply by anything. It tells you how many payments that you have. Your interest rate is 3% compounded monthly, so 3%. Your PV is what we're searching for. I'm going to put a 0 there as a placeholder. Your payment, you said you can spend $100 a month. So remember, loans, your payments are negative. You're going to spend 12 monthly payments, and it's compounded monthly, so that's all good. And then we're solving for our PV. So we can afford a $1,762.35 TV. So $1,762.35. Might not be getting that 72-inch. Sorry, fellas. Number 11, you want to invest in an annuity so that when you retire in 25 years, you can live comfortably. You invest in $10,000 into the annuity when you first open the account. Your investment will gain interest at a rate of 4.15% compounded annually. If you want to have $1 million in the account when you retire, how much do your monthly payments need to be? So in this case, we're investing, and you want to know how much your payments are. This one's kind of crazy, y'all, so stay with me. First thing that we need to do is find out how many payments are we going to make. Well, you have 25 years, and you're dealing with monthly payments. So this is going to be 25 times 12. Your interest rate is 4.15%. It's only compounded annually. We'll get to that in a second. Your PV is what we initially started with. That's your initial investment of 10 grand. Your payment is what we're looking for. I'm going to put a 0 there. So payment is 0. The future value, we want it to be $1 million. And this is where it gets kind of sketch. We wanted 12 payments a year, so monthly payments is 12 from this, but you also have compounded annually, so your compound periods are actually going to be 1, and your PY is going to be, or your payments per year is 12, and we're solving for our payment. So alpha, enter. So you're going to need, if you want that investment in that situation, you're going to need $1,971.06 for your investment. Number 12, you find your dream car, a Lotus Evora 400. They're bad, don't worry. Unfortunately, it costs $89,900. Your bank offers the deal of a lifetime, giving you a loan with 1.75% interest rate compounded monthly over a 7-year period. How much will your monthly payments be if you decide to buy the car? So in this case, we're looking at a loan. We know future value is equal to 0, and we're looking for our payments. So in this case, we're going back to our calculator. It says a 7-year period, and you're talking about monthly payments. So you got 7 times 12 for your N. Your interest rate, it said, was 1.75%. Your PV is the $89,900. That's the original for the loan. Sorry for the mishap with the calculator. Y'all know what's going on. We're solving for the payment. I'm going to put a 0 there for a placeholder. Future value, because it's a loan, is 0. And in this case, we're making monthly payments, so that is 12. And your interest rate is compounded monthly also, so that needs to be 12. And then we're going to go up, and we're going to solve for our payment. $1,136.25. $1,136.25. It's a bad car, though. Number 13, you decide to invest $1,000 of your money into a savings account that collects 2.85% interest compounded daily. How much will your account balance be after 3 years of not touching the money? So in this case, it's an investment. It says how much will your account balance be? So we're looking for future value. And now we go to our calculator. So since there's no payments, we actually could use that formula. I'm not going to. I'm going to continue to use this. So it says 3 years, and it's compounded daily. So 3 years, since there's no payments, the only payments we're getting is from that compounding interest. So times 365. Your interest rate, 2.85. Your PV is your initial investment of $1,000, not $10,000, but just $1,000. Your payment is 0. We're not doing any type of payment, so your payment is 0. Your future value is what we're solving for. Payments per year is going to be the same as your compounds, which is 365, and then solve for your future value. So after 3 years, you'll have a grand total of $1,089.26. Maybe not the best investment. 14, your grandpa put together an annuity when he was young. It has matured. When he began the account, he didn't initially put any money into the annuity. However, he put $50 in the account every month for 30 years. The account gains 2.35% interest compounded yearly. How much money does he currently have in the account? So this is an investment. The difference between this one and the last one is we do have a payment, but it says how much does he currently have in the account. Don't get this confused with present value, because we talked about grandpa and it's already matured. He did it when he was young, so this is actually the future value that we're searching for. A lot of people got that wrong in class. So your N is going to be 30 years times, it said he made monthly payments. Your interest rate was 2.35%. He didn't start with anything, so his present value was 0, but it did say he put $50 in. It's a positive payment because it's an investment. We're going to solve for your future value in a second. I'm going to put a placeholder right there. And then it said, what else? Interest was compounded yearly. So your compounding periods are 1, and he made 12 monthly payments. And you're solving for the future value. So in this case, we're going to hit alpha, enter, and our future value is $26,047.27. Number 15, you want to buy a house after you graduate from high school. You know that you can afford a $500 monthly payments and that you've been pre-approved for a loan at 5% interest rate compounded monthly. How much of a 30-year loan can you afford? So in this case, we're looking for a loan. Future value equals 0, and we're looking for the principal value, not equal to 0, but that's what we're searching for. So we're going to our calculator. So you're making monthly payments and you're doing it for 30 years. So 30 times 12. Your interest rate that you were approved for was 5%. Your PV is what we're searching for, so leave it at 0 for right now. Your payments, you're able to make a $500 payment. Remember, it's a loan. I almost messed up, but it should be negative $500. Future value, because it's a loan, is 0. Payments per year is 12. And then your compounding interest was compounded monthly, so that's 12 as well. And you're solving for your present value. So you can afford a $93,528.90 house. So $93,528.90. So with your $500 payment, got some good interest rate, $93,000 house. Number 16, you put $2,500 on a credit card and wanted to pay it off before 2017. You got 13 payments to do so. December this year, and then all 12 payments next year. If your car comes with a 20.25% interest rate compounded monthly, how much do your monthly payments need to be in order to accomplish your goal of no balance by 2017? So in this case, we're dealing with a loan, and we want to know how much payments are going to be. And we know our future value. I skipped that part, sorry. Future value is going to be 0. Go to your calculator. All right, and so in this case, we have 13 payments. It told us how many payments, so we're going to put the 13. Our interest rate was 20.25. Let's go back to that, my fault. Apparently it got mad at me. So we're going to go back. Excuse me, sorry for the delay. We're going to go to our apps, finance, TVM solver. All right, so we're starting fresh. In this case, we had 13 payments. Your interest rate was 20.25%. Your PV was what we originally had on the card, $2,500. Your payments, what we're solving for, I'm going to skip that. Future value stayed at 0. Your PY is how many payments that you're making in a year, so they're monthly payments. You're making 12 of them. And your interest rate was also compounded monthly, so I'm leaving that at 12. We're going back to solve for our payment, $215.78. Moral of that story, interest is crazy. All right, last part. We had a chart that we dealt with on this. Let me see if I can pull one up. Matter of fact, let me not do that. But based off of the chart, what I'll do is I'll give you some notes on this. How much did you initially borrow? When we had the chart, matter of fact, I might be able to pull this up. All right, so with your Microsoft Word, I can pull this up. We'll just use this. This was what you guys had. So with the chart that you had, looks something like that. Shrink it down a little bit. All right. So your first question said, How much money did you initially borrow? In order to find an initial borrowing amount, we can go straight up here to amount borrowed and look at that. It's $150,000. So this is with your amortization table. How much money did you pay in interest over the 30-year loan? Recognize I'm not giving you the full document. Notice you can see a split between the 12th payment and the $351st payment, but your interest total is going to be on bottom. I did that for you. So $156,606.06. So 156 606 and 6 cents. How much did you pay altogether for the life of the loan? Well, we can add those chunks together as far as interest and total amount we paid for principal. So in this case, if we add those two together, we should get $306,606.06. Let me rewrite that. Sorry, guys. So $306,606.06. If you sold the house after the first year for $152,000, how much money would you actually walk away with? So after the first year, we've made 12 payments, which means we still owe $147,979.37. So we don't get this whole $152,000. That would be nice, but that's not the way it works. We have to take away what we owe, which was $149,000. No, maybe it was $147,000. Let me go back to it. $147,979. And then we had some change too, 37 cents. I can't do that in my head, so I'm going to bring this up. And we have 152 minus 147, 979 and 37 cents. And so we get $4,020.63. If we sell it like that, what's the amount of your monthly payment? Well, monthly payments, we can look up here. $851.68 was my monthly payment. $851.68. Is that correct? Yep. And then the last one, how much of your payment went to interest on the 352nd payment? So in order to see how much goes to interest, we go to our 352nd payment right here. We go to our interest column. It was $34.34. So some things, remember, you're going to get to use this on your test tomorrow. Some things that you need to consider is answers don't mean squat in the long grand scheme of thing. You need to make sure to put yourself some notes. How did I find this? How did I do that? And little things like that on your test. Good luck. See y'all tomorrow.